10th Standard Science, Chapter 1, Laws of Motion. Choose the correct answer. First one, inertia of a body depends on option C answer, mass of the object. Second one, impulse is equal to answer C option, change of momentum. Third one, Newton's third law is applicable. Option C answer, both A and B. For a body is at rest, for a body in motion. Fourth one, plotting a graph of momentum on the x-axis and the time on y-axis. Slope of momentum time graph gives option C answer, force. Fifth one, in which of the following spot the turning of effective of force used? Answer option C, cycling. Sixth one, the unit of G is m S2. It can be also expressed as answer option B, N kilogram 1. Seventh one, 1 kilogram force equals to option C answer 98 into 10 to the power of 4 dyne. Eighth one, the mass of a body is measured on a planet Earth as m kilogram when it is taken to a planet of radius half that of the Earth, then its value will be dash kilogram. Answer option D, m kilogram. Ninth one, if the Earth shrinks to 50% of its real radius, its mass remaining the same, the weight of your body on the Earth will, option D answer, increase by 300%. 10th one, to project the rockets, which of the following principles required? Is or required? Then option D, both A and C. Newton's third law of motion, then law of conservation of linear momentum. Roman letter 2, fill in the blanks. First one, to produce the displacement, dash is required. Answer, force. Second one, passengers lean forward when sudden brake is applied in a moving vehicle. This can be explained by dash, inertia of motion. Third one, by convention, the clockwise moments are taken as answer negative and the anti-clockwise moments are taken as positive. Fourth one, dash is used to change the speed of car, gear. Fifth one, a man of mass 100 kg has a weight of 980 N at the surface of the earth. Third Roman letter, state whether the following statement are true or false. Correct the statement if it false. First one, the linear momentum of a system of particles is always conserved. The answer is false. The correct answer, in the absence of external force, the linear momentum of a system of particles is always conserved. Second one, apparent weight of a person is always equal to his actual weight. The statement is false. The correct statement, both the apparent weight and actual weight can be greater or lesser according to the movement of the person inside the lift. Third one, weight of a body is greater at the equator and less at the polar region. The statement is false. The correct statement, weight of the body is less at equator, more at polar region. Fourth one, turning a nut with a spanner having a short handle is so easy than one with a long handle. The statement is false. The correct statement, turning effect. Example, torque depends on a perpendicular distance of the line of action of the applied force. N is equal to F xd. Fifth one, there is no gravity in the orbiting space station around the earth, so the astronauts feel weightlessness. The statement is false. The correct statement, When a space station and astronauts have equal acceleration, they are under free fall condition. So both astronaut and space station are in the state of weightlessness. Fourth Roman letter, match the following answers. இதில் ஆன்சர்ஸ் வந்து ஸ்ட்ரைட்டாகவே எழுதியிருக்கு. ஃபர்ஸ்ட் ஒன் ஆப்ஷன் ஏ நியூட்டன்ஸ் லா, ஸ்டேபிள் ஈக்லிபிரியம் ஆஃப் எ பாடி. தென் ஆப்ஷன் பி நியூட்டன்ஸ் செகண்ட் லா, லா ஆஃப் ஃபோர்ஸ். நியூட்டன்ஸ் தேர்ட் லா, flying nature of bird. Then option D, law of conservation of linear momentum. Answer, propulsion of a rocket. Fifth one, assertion and reasoning. Mark the correct choice as option A, if both the assertion and the reason are true and the reason is the correct explanation of assertion. Then B, if both the assertion and the reason are true but the reason is not the correct explanation of the assertion. C, assertion is true but the reason is false. Then D, assertion is false but the reason is true. First one, assertion. The sum of the clockwise moment is equal to the sum of the anti-clockwise moments. Reason, the principle of conservation of momentum is valid if the external force on the system is zero. Answer, option B, if both the assertion and the reason are true but the reason is not the correct explanation of the assertion. Second one, assertion. The value of G decreases as the height and depth increases from the surface of the earth. Reason, G depends on the mass of the object and the earth. Answer, option C. Answer, assertion is true but the reason is false. Sixth Roman letter, answer briefly. First one, define inertia, give its classification. Inherent property of an object to resist any change in its state of rest or the state of uniform motion unless it is influenced upon by external unbalanced force is known as inertia. Second one, classify the types of force based on their application. There are two types of force. First one, contact force. A force which is applied by means of direct physical contact between two objects is known as contact force. Examples, pushing or pulling an object, muscular force, frictional force, compressing a spring, kicking a football, etc. Then second one, non-contact force. A force which is applied without any physical contact between the objects is known as non-contact force. Example, gravitational force, magnetic force, electromagnetic force, etc. Third question, if a 5n and a 15n forces are acting opposite to one another, find the resultant force and the direction of action of the resultant force. F1 is equal to 5n, F2 is equal to 15n, R is equal to F1 plus F2 equal to F1 minus F2 is equal to F5 minus 15. The resultant force is equal to minus 10n. The resultant force of minus 10n is acting in the direction of 15n. Fourth one, differentiate mass and weight. Mass, first one, it is the quantity of matter contained in the body. Second one, mass is a scalar quantity. Third one, its unit is kilogram. Fourth one, mass of a body remains the same at any point on the earth. Fifth point, mass can be measured using physical balance. Weight. First point, it is the gravitational force exerted on a body due to the earth gravity alone. Second point, weight is a vector quantity. Third one, its unit is n, Newton. Fourth one, weight of a body varies from one place to another place on the earth. Fifth one, weight can be measured using a spring balance. Fifth question, define momentum of a couple. Couple. Two equal and unlike parallel forces applied simultaneously at two distinct points constitute a couple. The line of action of two forces does not coincide, it does not produce any translatory motion since the resultant is zero, but a couple results in causes the rotation of the body. Rotating effects of a couple is known as moment of a couple. Example, turning a tap, winding or unwinding a screw, then spinning of a top, etc. Sixth question, state the principle of moments. The principle of moments states that when a number of like or unlike parallel forces act on a rigid body and the body is in equilibrium, then algebraic sum of moments in clockwise direction is equal to the algebraic sum of moments in unclockwise direction. Moment in clockwise direction equal to moment in anti-clockwise direction. F1 into D1 is equal to F2 into D2. Seventh question, state Newton's second law. The force acting on a body is directly proportional to the rate of change or linear momentum of the body, and the change in momentum takes place in the direction of force. F is equal to m into a, force is equal to mass into acceleration. Eighth question, why a spanner with a long handle is preferred to tighten screw in heavy vehicles? The turning effect of a body depends upon the distance of the line of action of the applied force from the axis of rotation. Larger the perpendicular distance, lesser is the force required to turn the body, so spanner with long handle is preferred. Ninth question, while catching a cricket ball, the fielder lowers his hands backwards. Why? When the fielder pulls back his hands, he experiences a smaller force for longer intervals of time, leading to less damage to his hands. 10th question, how does an astronaut float in a space shuttle? First point, both the astronauts and the spacecraft experiences the same gravitational force of the earth. Second point, there is no weight of the astronauts extracted on the surface of the spacecraft. Third point, in turn, there is no reaction force exerted by the surface of the spacecraft on the astronauts. R is equal to 0, so they float. 7th Roman letter, solve the given problems. First one, two bodies have a mass ratio of 3:4. The force applied on the bigger mass produces an acceleration of 12 ms minus 2. What could be the acceleration of the other body if the same force act on it? Mass ratio of two bodies is 3:4. So let's assume mass of smaller body is equal to m1 equal to 3 kilograms. Mass of bigger body is equal to m2 equal to 4 kilogram. Acceleration due to force applied by bigger body equal to A2 equal to 12 ms minus 2. To find acceleration due to the same force on the smaller body equal to A1 is equal to question mark. Solution, according to Newton's second law of motion, F is equal to m into A, F1 is equal to m1 A1, F2 is equal to m2 A2. F1 is equal to 3A1, F2 is equal to 4 into 12 is equal to 48N. As the force is the equal, F1 is equal to F2, 3A1 is equal to 48, A1 is equal to 48 by 3 is equal to 16 ms minus 2. So, acceleration due to the same force on the smaller body A1 is equal to 16 ms minus 2. Second one, a ball of mass 1 kilogram moving with a speed of 10 ms minus 1 rebounds after a perfect elastic collision with the floor. Calculate the change in the linear momentum of the ball. Given mass m is equal to 1 kilogram. Initial velocity u is equal to 10 ms minus 1. Final velocity v is equal to 10 ms minus 1. To find change in linear momentum equal to mv minus u is equal to mv minus mu. Solution: momentum before collision is equal to mu equal to 1 into 10, then is equal to 10 kilogram ms minus 1. Momentum after collision is equal to mv, then equal to minus 1 into 10, then is equal to minus 10 kilogram ms minus 1. Change the momentum is equal to mv minus mu, then is equal to minus 10 minus 10. Answer I equal to minus 20 kilogram ms minus 1. Third one, a mechanic unscrew a nut by applying a force of 140 N with a spanner of length 40 cm. What should be the length of the spanner if a force of 40 N is applied to unscrew the same nut? Given force F1 is equal to 140 N, length L1 is equal to 40 cm. Equal to 40 into 10 to minus 2 m. Force F2 is equal to 40 N. Length L2 equal to what? To find F1 into L1 is equal to F2 into L2. The length of the spanner L2 is equal to F1 into L1 bar F2. Solution: L2 is equal to 140 into 40 into 10 to the power minus 2 bar 40 is equal to 140 into 10 to the power of minus 2. The length L2 is equal to 1.4 m. Fourth one, the ratio of masses of two planets is 2:3 and the ratio of their radii is 4:7. Find the ratio of their acceleration due to gravity. The ratio of masses of two bodies of m1 is to m2, Le 2:3. The mass of the smaller body m1 equal to 2 kilogram. Mass of the bigger body m2 is equal to 3 kilograms. Radius of the smaller body r1 is equal to 4 kilometer. Radius of the bigger body r2 is equal to 7 kilometers. Example: r1 is to r2 equal to 4 is to 7. Solution: we know that gm by r squared, g1 is equal to gm1 by r1 squared 2, g2 is equal to gm2 by r2 squared 2, then g1 by g2 is equal to gm1, then r1 squared 2 by gm2 by r2 squared 2 is equal to m1 by r1 squared 2 into r2 squared 2 by m2. g1 by g2 is equal to m1 by m2, then r2 by r1 squared minus 2 by 3, 7 by 4 squared 2. g1 by g2 is equal to 2 by 5 into 7 into 7 by 4 into 4 is equal to 49 by 40. The ratio is g1 is to g2 equal to 49 is to 24. 8th Roman letter, answer in detail. First one, what are the types of inertia? Give an example for each type. Answer, first point, inertia of rest. The resistance of a body to change its state of rest is called inertia of rest. Example, when you vigorously shake the branches of a tree, some of the leaves and fruits are detached and they fall down. Then second point, inertia of motion. The resistance of a body to change its state of motion is called inertia of motion. Example, an athlete runs some distance before jumping because this will help him jump longer and higher. Third point, inertia of direction. The resistance of a body to change its direction of motion is called inertia of direction. Example, when you make a sharp turn while driving a car, you tend to lean sideways. Second question, state Newton's laws of motion. Answer, Newton's first law. Every object continues to be in its state of rest or the state of uniform motion along a straight line unless it is acted upon by some external force. Second point, Newton's second law of motion. The force acting on an object is directly proportional to the rate of change of linear momentum of the object, and the change in momentum take place in the direction of force. This law helps us to measure the amount of force, so it is called as law of force. Third point, Newton's third law of motion. Newton's third law states that for every action there is an equal and opposite reaction. They always act on two different bodies. Third question, reduce the equation of a force using Newton's second law of motion. Answer, first point, let m be the mass of moving body moving along a straight line with an initial speed u ms minus 1. Second point, after a time interval of t second, the velocity of your body changes to v ms minus 1 due to the impact of unbalanced external force F. Third point, initial momentum of the body P1 equal to mu. Fourth point, final momentum of the body P1 is equal to mv. Fifth point, change in momentum, then P equal to Pf minus Pi is equal to mv minus mu by Newton's second law of motion. Force Fa, rate of change of momentum. Fa, change in momentum bot time. Fa, mv minus mu bot t. F equal to km v minus u t. Since acceleration, change in velocity bot time, a is equal to v minus u bar t. Then sixth one, hence we have F is equal to m into a, force is equal to mass into acceleration. Fourth one, state and prove the law of conservation of linear momentum. Answer, the principle of conservation of linear momentum states that there is no change in the linear momentum of a system of bodies as long as no net external force act on them. Let us prove the law of conservation of linear momentum with the following illustration. The conservation of linear momentum இதை draw பண்ணிக்கங்க. Then conservation of linear momentum. Proof, let two bodies A and B having masses m1 and m2 move with initial velocity u1 and u2 in a straight line. Let the velocity of the first body be higher than that of the second body. Example, u1 then greater than u2. During the interval of time t second, they tend to have a collision after the impact, both of them moving along the same straight line with a velocity v1 and v2 respectively. Force on body B due to A, Fb is equal to m2 v2 minus v2 slash t. Force on body A due to B, Fa is equal to m1 v1 minus u1 then bar T by Newton's third law of motion, action force, then reaction force equal to reaction force, Fa is equal to minus Fb. M1 V1 minus U1 bar T is equal to M2 V2 minus U2 bar T. M1 V1 plus M2 V2 is equal to M1 U1 plus M2 U2. The above equation conforms in the absence of an external force. The algebraic sum of the momentum after collision is numerically equal to the algebraic sum of the momentum before collision. Hence, the law of conservation of linear momentum is proved. Fifth question, describe rocket propulsion. First point, propulsion of rocket is based on law of conservation of linear momentum as well as Newton's third law of motion. Second point, rockets are filled with a fuel, either liquid or solid, in the propeller. Third point, when the rocket is fired, this fuel is burnt and a hot gas is ejected with high speed from the back nozzle, producing a huge momentum. Then fourth point, to balance this momentum, an equal and opposite reaction force is produced which makes the rocket project forward. Fifth point, while in motion, mass of the rocket gradually decreases until the fuel is completely burnt out. Since there is no net external force acting on it, the linear momentum of the system is conserved. Then sixth point, the mass of the rocket decreases by altitude that results gradual increase in velocity of the rocket. Seventh point, at one stage it reaches a velocity which is sufficient to just escape from the gravitational pull of the earth. This velocity is called escape velocity. Sixth question, state the universal law of gravitation and derive its mathematical expression. Newton's universal law of gravitation. This law states that every particle of matter in this universe attracts every other particle with a force. This force is directly proportional to the product of their masses and inversely proportional to the square of the distance between center of these masses. The direction of the force acts along the line joining the masses. Deviation. Let M1 and M2 be the masses of two bodies A and B placed at or meter apart in space. Force F meter M1 into M2 F 1 bar r squared. On combining the above two expressions, F M1 into M2 bar r squared, F is equal to G M1 M2 r squared or G M1 M2 bar r squared, where G is universal gravitational constant. Its value in SI unit is 6.674 into 10 to the power of minus 11 Nm squared to kilogram minus 2. Gravitational force between two masses. இது எழுதிக்கங்க. Gravitational force between two masses. Seventh question, give the applications of universal law of gravitation. Application of Newton's law of gravitation. Dimension of the heavenly objects can be measured using gravitation law. Mass of the earth, radius of the earth, acceleration due to gravity, etc. can be calculated with a higher accuracy. Second point, helps in discovering new stars and planets. Mass of the double stars can be calculated. Third point, one of the irregularities in the motion of stars is called wobble, which leads to the disturbance in the motion of planet nearby. In this condition, mass of the star can be calculated using law of gravitation. Fourth point, helps to explain germination of roots due to the property of geotropism, which is the property of root responding to the gravity. Fifth point, help to predict the path of the astronomical bodies.